Ladies and gentlemen, in this video we are going to be practicing how to draw Lewis molecules, Lewis structure molecules, and then use that to predict the shape that molecule is going to have. So if we look at our first example, we have phosphorus tribromide. So before you build your molecule, you're going to want to see what each of those Lewis structures look like for the individual atoms. So looking at my periodic table, I'm going to find P for phosphorus, and I'm going to see that it's in group 15. So that's the same thing as group 5. So I'm going to draw 5 dots around my P, one at a time, to indicate that it's 5 valence electrons. Now I'm going to do the same thing for Br. Br is located here, and it's in group 17, which is the same thing as group 7. So I'm going to draw 7 dots, one at a time, on each side for bromine. Okay, so when I draw those different Lewis dots, I can see that my bromine has 3 electrons that are available to share. So that tells me that phosphorus can form 3 single bonds. Now my bromine only has one spot where it can form a bond. So this one can form 1 single bond. So right away I can see that phosphorus has more connections, so that's going to be my central atom. So I'm going to draw phosphorus in the middle with its 5 valence electrons. And then I'm going to draw my bromine on each side where there's an unpaired electron. And then I'm going to draw the 7 valence electrons around each bromine. Now, after I do this, every atom should have a full octet, because that is why atoms want to bond. Now I can clean up my picture as well, so I don't have all these dots all over the place. So phosphorus, we said, will have 3 connections, or 3 single bonds. And I have 3 bromines that it needs to bond with. I'm going to carry over my lone pair of electrons. So that's my lone pair. And then I'm going to also make sure I finish off my structure. Okay. So this is what the structure would look like. And now based on my structure, I can count how many domains I have, which will then help me determine the shape. So I have 1, 2, 3, 4 domains around my central atom. And 3 of those are shared pairs, and 1 is a lone pair. Now I'm going to look at my shape sheet, and I'm going to find 4 domains, and it has 1 lone pair, so that tells me that my shape is going to be trigonal pyramidal. And anytime we have a lone pair on our central atom, we know the molecule is going to be polar. Okay, so this is a trigonal pyramidal molecule, and we know that it is polar. Okay, all right, let's try the next one. Here we have a hydrogen, which is in group 1, so it has 1 dot, and then we have bromine again. Now we had bromine up here, so I don't have to show you on the periodic table. You already know it's in group 7. So that's what bromine looks like, and that's what H looks like. We can see each of them has 1 electron that can be shared together, and there's only 2 of them, so we don't have to try and figure out which one's in the middle. We just need to draw that single bond between the 2 atoms. And then we want to finish off our bromine with the full octet. And here we can see we've got hydrogen bonded to bromine, and there's more electrons over here on bromine, and bromine is the more electronegative element. So I'm going to go ahead and draw a dipole arrow towards my bromine, And even though this is a linear shape, we can see that this molecule, that it is going to be polar. And that's because there is a difference in electronegativity that is greater than 0.4. Now, I didn't look up these numbers, but I can just tell that bromine is very electronegative. It's furthest to the right. It only needs one more. So that's how I know it's going to be a polar molecule. All right, let's look at this third one. We've got H2S. So whenever you have an H, you know H's are always going to be on the outside because H's cannot share more than one electron. So I'm going to draw my H's on the outside with one valence electron. Now when I find S, S is right here. It's in group 6, so it has 6 valence electrons. So I'm going to draw my S in the middle. 1, 2, 3, 4, 5, and 6. So I can see I'm going to be forming a single bond here and a single bond here. So I'm going to clean this up. So there's my single bond. There's another single bond. And then I'm going to draw my 2 lone pairs on the top and bottom, showing my full octet for S. And now I can see I have 1, 2, 3, 4 domains. And in those domains, 2 of them are lone pairs. So I'm going to look at my shape sheet. Here's my 4 domains, and I have 2 lone pairs. So this is going to be a bent molecule. So if I were to draw it, this is what it would look like. And that's because we have these negative lone pairs on top of this part of the molecule, creating that very negative section of the molecule. So this is a very polar molecule because it has 2 lone pairs of electrons. And we said it was bent. Okay, one more to go. Here we have 3 different elements, and we already know hydrogen has to be on the outside. So hydrogens are going to be on the outside. I'm just going to draw 2 hydrogens. Now we're trying to figure out what's going to go in the middle. Is it going to be carbon or is it going to be fluorine? Now carbon is right here, and it's in group 14 or group 4. So it only has 4 valence electrons. With 4 valence electrons, it could do 4 single bonds. It could do 2 double bonds. It could do 1 triple bond. So carbon has a lot of flexibility, which is why it normally is in the middle. Fluorine has 7 valence electrons because it's in group 7. It's a halogen. It's right here. Okay, so I know that fluorine is going to be on the outside. And I know that fluorine can make 1 single bond. So I'm going to draw my 4 valence electrons for carbon. This is going to make a single bond here. This is going to make a single bond here. And this allows me to put down my 2 F's in the other spot. And I'm going to draw in my 7 valence electrons. Okay. So now I have a shared pair here, a shared pair here. I have 4 shared pairs. So with 4 shared pairs, we can see that we have a tetrahedral molecule. I have 4 domains and 0 lone pairs. 4 domains, 0 lone pairs gives me a tetrahedral molecule. And that is how we figure out our shapes.